Just give it another second. All right. Can everyone hear me? Any new folks joining the session today? Anyone new? No?
Yeah.
Everyone's here before? Yeah.
I just come here to take a look at what's going on is llm-d stuff. So yeah, it's first time to join this call.
Cool. You mind? Do you want to introduce yourself?
Oh sure. I'm from Red Hat. I'm working on OpenShift AI team, the modern serving team, and also contributed to Kserve for integrating llm-d stuff these days. Yeah, that's pretty much.
Sounds good. Anyone else joining for the first time?
Yeah, me too. I'm a Tharva. I work on Instruct Lab at Red Hat as well. And just joining in to see where PD disaggregation development is going.
Sounds good. John, I think this maybe is your first time in this meeting. Do you want to just introduce yourself to the group?
Yeah. Hi, everybody. My name is John. I've been working with Rob and folks from Neuromagic Red Hat on this aggregated serving. Looking at kind of the overall architecture. Happy to have any discussions with anyone here.
Cool. And then David, I think you might be new to this call as well. Do you want to introduce yourself?
Yeah, sorry, I'm late first. Had trouble joining. I'm David. I'm from Plyops. Last week, Phil was here. Interested in KV cache offloading. Currently working on bad path flow, error loading KV cache blocks. That's about it. Happy to be here.
Cool. Well, welcome. Their open items open is reverse flow. Okay. So before I kind of dive in to just give an update on like the open work streams that we have right now, is there anything that folks want to discuss in the open forum? Any other like ad hoc topics? No? Okay. Quiet group today. All right. So in terms of active work streams, one of the main ones we've had going on for a couple of weeks is finalizing the protocol. With the original llm-d release, we implemented, a first kind of prototype of PD disaggregation, aligns to some of the North Star docs that John had put together from Google. So after this, we've done a little bit more thinking about, the handshakes that various instances have to do to, establish a KV transfer, as well as the protocols associated with the transfers, that the GIE is going to, add into the request payloads. So we have kind of a formal proposal for this that we've, coalesced around over the course of the last 2 weeks. And there's some ongoing work from Will at Red Hat to implement some of the changes into the VLLM schemas. And then we will be, posting this as a formal kind of PR to, demonstrate the APIs, for the protocol. So please feel free to take a look in the doc if there's anything in particular. But, this is really just about formalizing the, API. So any questions about that? Any other concerns? I think we're in a pretty good spot, but yeah, I'll just kind of see. Okay. So next, beyond this, we're spending some time benchmarking the single node PD setup. We're looking at a couple of different cases. First is heterogeneous TP has been enabled. This is a really key feature. One of the kind of main optimizations that we have in PD disaggregation is the ability to specialize the prefill and decode workers for better performance, basically, where we can create a prefill worker that's targeted at doing prefill. Typically, the prefill workers are going to be using less parallelism. So the prefill workers will are generally going to be doing compute bound computation. They don't often have as much KV cache memory that needs to be utilized. So the way that we're planning to work on as a setup is to look at a model like Llama 4 Scout, where we can run it at TP1 on a few kind of nodes, and then look at a wider TP for the generation phase of the model. So TP8 or EP8 for the kind of Llama 4 Scout decode worker. And we believe that this optimization will really help to demonstrate to get better performance for the PD setups. So this is ongoing. We had some issues with our cluster over the course of the last few days that are back online, but this is kind of a near-term target that we're looking at. So L4 Scout, basically TP equals 1 for P worker, TP equals 8 for D worker. We want to try to demonstrate the scenarios where we get a performance win. So this is kind of a big item. Definitely could use some help on this. Like, folks want to spend time. John, yeah, go ahead.
So for this one, right, it is for the case we're picking P and D together, right? Because I'm assuming we are doing the shape transform before transfer, right?
That is correct. This is like the current design. That's the other kind of open item we have. Reverse request flow. Open. Now it's remove sidecar and delay P/D decision. Yeah. But yeah, like I think we just want to kind of we did a bunch of work at the last couple of days to basically improve the performance of the KV transfer, add more features to it. And so, the goal is to get another kind of benchmark in place for this. I've been trying to do this the last few days, but our cluster was broken. So yeah, ran into some infrastructure issues. So yeah, this has gotten a little bit delayed.
Okay, so kind of from the inference gateway perspective, right? For this one, if we're picking P and D together, do you need information on the TP of D to be able to do it?
On the TP of
the D worker, because right now what we're giving you is the IP address and port number for the D worker, right? Oh, sorry, for the actually we're sending into D first, and then that goes to P. Actually, that might be okay because that's going to that can be passed on the metadata call, actually, right?
So it's actually not in the KV transfer metadata. It's not in the KV transfer params. It's part of the KV transfer metadata. So during the initial Nixel handshake, basically the D worker discovers what the
okay, makes sense. Good. Okay,
this is already working. So GIE doesn't have to know this, but one thing that there is currently in the design a requirement on is that the D workers need to have more or equal TP than the P workers do. So you can't have a P worker with TP 8 and a D worker with TP 1. This is not something that we currently support. I do think that this actually should be something that we can do, but like we don't have this implemented so far. So like, let me actually take this as an open item.
Makes sense. Okay,
Support
thanks.
Arbitrary. I think we will have to do, multiples of 2, but I think, or not, multiples of 2, but I think that should be okay. Support arbitrary TP mix. So right now we have TP of P greater than less than TP less than or equal to TP D as requirement. Basically, the key kind of blocker on the heterogeneous TP before was that the KV cache layouts were not conducive to, because basically like when you do heterogeneous TP, basically the D worker is going to pull, like when we shard the KV cache, we shard the KV cache, we have, we shard the KV cache on the KV heads dimension. So
yeah, exactly.
And so the key problem was that the way that we laid the KV cache out in memory was like the KV heads dimension was like right in the middle of basically like the tensors. And so like basically a KV head block was not like contiguous. And so you had to like basically do these like really small, like RDMA reads. And so like the way that we got around this problem and like is basically we rearranged the way that we're laying out the KV cache in VLLM such that like it's contiguous.
Oh, yeah. I remember that. Yeah. I remember that.
That was like
Okay.
the key optimization that we like had to do. And so like basically like it ends up being okay because like we modified the attention kernels to like be able to work properly like in this context. So anyways, like we made some changes in VLLM that made heterogeneous TP kind of work, and this resolved all the problems where like so what we were seeing before was like the reads, like the RDMA transactions were like 100 and like each block was like 120, like basically a kilobyte. And now it's like, if you do block size 128, it's 100 times bigger. And so there's way fewer like reads that are going on because we like laid out the KV cache in the proper way. The reason it took a long time to discover this was basically it looked the same from like the VLLM level, but Nixel was actually like one of the Nixel APIs was actually like merging together adjacent blocks if it was possible. And so anyways, that's how we like figured this out. And so this is a critical optimization, and we're pushing to get some better benchmarks on this now.
Makes sense. So just one more follow up on this one. When it comes to say MLA, like DeepSeek models, right? The KV cache is no longer sharded by KV head because is all represented in the latent space. In that case, we'll just the TP for the attention layers in that case would just duplicate all the KV cache everywhere, right? Across all. If we are doing TP, yeah.
But we won't do TP for attention.
We won't do TP, then it doesn't matter. Yeah.
So I think we probably need to like. I believe that this should work for DeepSeek. I believe this should work
for DeepSeek, right? Because if we are still partitioning the KV cache attention heads, we can't do that anymore with MLA, right? Because the whole thing is on the latent space. If we are still wanted to do certain TP, but then we'll have to basically duplicate.
I think like our canonical deployments for DeepSeek will just not have TP sharding for the.
Okay, that makes sense.
We're gonna do DP. We're gonna do So I don't think we should like. I want to make sure it doesn't like break if somebody deploys it that way. But like I think we should kind of optimize the DP case for MLA as opposed to the.
So in the DeepSeek technical paper, they actually do TP equal to 4. But I think they just replicate the KV cache for their TPs.
I see.
Oh, all right. Let's move on to Anili.
Yes, so a few things. First is that I from what I heard, I think that the scheduler should be aware of the TP when currently choosing the DNP worker, because you said that the P cannot be greater than the TP of the P cannot be greater than the decode. So this is something that we need to add this awareness, Rob, unless you're saying that changing this constraint is something that's going to happen really fast, because currently we are not taking this into account when choosing P.
I know, but like I think like in reality, like I think for like the very short term, like in reality, like we're going to deploy D workers that have wide parallelism and deploy P workers that have like skinny parallelism. We're not like we're currently inside of llm-d. We don't like dynamically update, you know, the role that a worker is playing in a particular deployment. That being said, like as we think about adding more advanced scheduling down the road, like where let's say the P workers are super overloaded, like I don't know, like, or let's say the D workers are really, I don't know. You could imagine a scenario in the future where we might not have a static set of nodes that are P and a static set of nodes that are D. And in reality, things are a little bit more fluid with respect to the role that a particular particular replica is playing. I think for now it's okay because like we'll just deploy the P work like where we currently have static assignments of the roles. It's okay. Yeah.
Okay, and another thing regarding the sidecar and its removal, I do think that we need to first validate that the new approach of deferring the decode worker has a value, because you have this benchmarking, and I do think that we need to, check that adding this complication to VLM is beneficial, and that then the other thing, even if it is, I think that we should not disable this flow of choosing them together, meaning that if you are disabling the sidecar, it should still allow this flow, having sidecar optional, if we want to, making sure that VLM still support this flow of choosing them together, because currently I understand that we are not benefiting from choosing decode first, but if we would like to, do pre-allocation of the KV blocks in the decode and then using a push instead of pull, this could be something that will be valuable. So we need to maintain this decode pre-fill ability to do that also. Just wanted to make sure we are aligned on that.
Yeah, I mean, we've talked about this like almost in every single meeting, that like we're going to do both patterns.
Okay.
Like,
I think the question is, Rob, if we are going to do both with VLLM, or we for a while keep sidecar. And
I think like one of the things that I find to be like we need to demonstrate that our system is getting performance wins before we consider adding every single flow into the overall project. And so I would like for us to focus on the current kind of first flow that we want to deliver and focus on making this work really, really, really well before we start adding like all these different directions into the project. So I want to focus our like efforts this week onto the benchmarking, items that we have in front of us.
okay.
Agreed.
All right. The other big item that's going on is, so this is a single node setup. We're also focusing on the multi-node setup, mostly focused on the large scale MOEs. So there's been a big effort, to address some of the items that like John was talking about with the DP, attention, EP, MOE kind of side. So in particular, there's been a good proposal that's been put out around the data parallel deployments. We've been thinking through this kind of like one pod per DP rank kind of setup, where the instances are deployed via LWS, and then every single VLLM DP rank gets its own pod, which allows the scheduler to connect to the, which allows us to really not have to make any modifications to the inference scheduler to load balance across the DP ranks. So there's a design that Nick put out, some changes being made in VLLM to support this, and generally ongoing work to enable this kind of setup. Tyler's also been benchmarking some of the performance of VLLM inside of these wide parallel designs, and we have some ongoing work to make this work better. For instance, EPLB, as well as DBO, dual batch overlap, are two performance features that are still ongoing in the VLLM side, which will help with this work. It's a little bit orthogonal to PD disaggregation, but it is important to make these wide-scale mixture of experts models work well. Then the last kind of big item is there's a few open PRs related to TCP-based transport. These are making good progress, but we'll be planning to kind of land these and start looking into the performance of these as well. I actually don't have much of an update on the TCP side. I don't know if anyone here has been looking into it. No. Okay. David, do you want to talk about some of the items you've been looking at? Or sorry, did Marin, do you have your hand up?
Yeah, I have a question on the first point, the heterogeneous TP. Do you have any idea if there's preference for some matchings above others? Like, for example, would you heavily prefer PD pickups of the same TP ranks, or like some kind of formula that specifies which are more performant, or is that not a thing? The idea is optimizing the selection of both based on TP.
I think that in general, like just conceptually, we have two different workloads, which is prefill is a compute bound workload and decode is a memory bound workload that requires a lot of KV cache state. So in general, the D workers are going to be specialized to do decode work, which means we want to have as little memory as possible being consumed by the weights to make as much KV cache space as possible. And then we want to use wide parallelism to, because the collective communication costs in a memory bound use case are lower in comparison to what they are for prefill. So the prefill workers are going to be specialized for doing prefill with less parallelism. So ideally TP1, and the prefill workers are going to have wide parallelism for, TP8, or in the case of DeepSeek, for instance, the prefill workers are EP32 and the decode workers are EP144. So like you can see that's totally kind of different. And so the thing I think we need to get working as our kind of original layout, our first kind of target is static P, static D. Like how much benefit do we get from this specialization as compared to like a homogeneous deployment? I think that as we start looking at like more sophisticated patterns in the future where, there's prefix cache hits in some places and not others, and certain instances are overloaded versus not, we can make a more complicated decision in the scheduler. But I think that the current kind of setup with static set of P workers and static set of D workers will get us, the 80-20 of like where we want to go, like as it relates to the benefits of specializing the instances.
Okay.
Zola, did you have something?
Yeah, I guess then your last comment actually answered my question. Is asking if we ever envision that we were going to auto scale a DP deployment at all. If yes, I would love to know about it soon. Like, I mean, I'm not like, I don't know, understand the full details in VLLM, so I have no idea about the feasibility of it as well. But if there is, I would like to know about it soon so that we can take that into account in LWS design. Right now, LWS doesn't support auto scaling a single, group of pods. If possible, we're just not making it happen right now.
Well, I think there's like a couple of pieces, which is like one of the things that like is very clear to me about PD from like doing my benchmarks is there's certain workloads where it's going to really help. And depending on the mix of the workload in terms of the amount of number of input tokens versus number of output tokens, like the relative amount of prefill workers versus decode workers that you have will mix, right? It's like if you have the average prompt is 10,000 versus 100,000, you obviously need like just a different number of prefill workers.
Yeah. I'm talking like the ratio between P and D. I'm talking about within a P, like, like for example, a DeepSeek deployment, you will have, I don't know, 12 pods, right? Because you have data parallelism there. Would you ever need to autoscale that to change your DP on the fly?
Yes, so I think this is something we need to take a deeper look, because this is where I'm hoping like Jan can give up some answers. Like one thing that we need to look at is on VLM, right, is configuring NV share mem. For that configuration, does it constitute a restart? If it doesn't constitute a restart, we can do this at runtime. Then we can add EPs without triggering any restart. This all happens at runtime. Then that's becoming more feasible, right? But if it requires a more kind of like a global reconfiguration, then that will constitute a restart. So that's something we need to look deeper. I'm hoping Jan can give us more details as he kind of get more into the project.
Right. So the feasibility of the other one is actually going to be ever useful, right? Like, will we ever have like a type of workload that, it makes sense.
I think it will be useful. This thing for sure will be useful. It's just may not be feasible.
It could be useful for like the concept, like the process of like reassigning a node from being a pre-worker to a D worker. You know what I mean? Like if you did it in some ways, like what you want to do is like, like if you have a D worker that's deployed with 8 nodes and you want to convert that into 4 prefill workers that each have like 2 nodes attached to them, like would this process be a way to kind of make that happen more efficiently? I don't know.
Right.
I'm not sure.
Rob, another way to kind of frame this is, let's say we wanted to kind of scale it up, right? One way to scale it up is to add DP, therefore adding EP, right? That's one way to scale it up. Another way to scale it up is just adding pure replicas of the same thing. At some point, we want to make a decision on, is it more efficient to add EP? Is it more efficient to actually just add whole replicas? That's the lever that we can potentially have if we can do this at runtime and if this is feasible.
Yeah, exactly.
Okay. David, did you want to give an update on some of the items you were working on?
Yeah, sure. So I was working on adding some fault detection and recovery to the KV connector abstraction. So basically, currently, VLLM lacks any mechanism to detect and recover from KV load failures in particular. That's what I focused on initially. So if one or more KV blocks fail to load, currently it may lead to system instability, like crash or halt in the wait for layer load API. And in the worst case, it may not halt there, but instead it will lead to incorrect outputs, like invalid, corrupted KV cache blocks. So what I suggested is a very, very basic mechanism where we allow the forward pass to complete, even if some of the blocks fail to load. But eventually, after the forward pass completes, we allow the KV connectors to report which blocks fail to load, to report the block IDs. And we propagate this information back to the scheduler. And then it can reschedule the requests that fail to load some of the blocks. And it simply updates their computed blocks to the last to the longest valid prefix. Okay, so I actually implemented this mechanism. You can take a look. I have also some very basic example based on the offline inference example of the shared storage connector. But the gap that I have is that in case we have a TP setup where we have multiple workers, we currently only report the model runner output of the first worker of the last pipeline rank, right? So it is actually up to the connector implementation to do the aggregation. Similar to how the Nixel connector aggregates the finished request, right? So I saw that Orozeri is working on some solution to do this aggregation at the scheduler level. I was kind of aiming to the same to a similar solution. I saw that he opened the PR today. I didn't get a chance to look at it yet, but hopefully I will be able to adapt his suggested solution.
Sounds good. Could you add a link to the PR into this doc so I can take a look at it?
Yeah, this is really cool, by the way. Yeah, this is awesome. On retries and fault tolerance. Yeah.
Okay, we'll add it here. Is it shared somewhere, this document?
It's in the notification. It's in the Cal invite.
Oh, yeah.
All right. I have to drop, everybody. Thanks a ton for the time. Thanks for the updates. Have a good rest of the day. Bye now.
Thank you.